41. Determine the bond order of each member of the following groups and determine which member of each group is predicted by the molecular orbital model to have the strongest bond. And then we have O2, we have O22 plus and O22 minus. So first things first, we have to find the bond order of each member. Now, before we find a bond order, this all comes back to your valence electron molecular orbital configurations, which is this mess down here. But it's all based off of valence electrons. So the first thing that we got to figure out is how many valence electrons are in these three species. So let's start with O2 without a charge. And I'll put O2 over in the middle. Now O2, oxygen, right? If I look on the periodic table for where oxygen is in group 6A or 16. Depending on what your periodic table says as your group values. But the lucky number here is 6, because oxygen has 6 valence electrons. But now I have 2 oxygens, so twice the number of valence electrons. So I'll take my, maybe I'll just say it over here, I have 2 oxygens, and I'll times by 6 to say that I now have a total of 12 valence electrons. And that's going to be super important in a little bit. Now, the next thing we have to do is we're going to basically take those valence electrons and put them in our template. But we have to first pick the right one. Different groups call for different templates. And there's only 2 different types of valence electron molecular orbital configuration templates. This is due to different groups having different mixing of your s and p orbitals. But for now, just know that there are 2 separate ones, and you can easily find them out by which one's going where by their group number. Since we said that O2 was already in group 6A, we're going to be using the bottom one. So what I'm going to do is I'm just going to pull the bottom one up, and we can forget about the other one for this question. So pause the video if you want to write the other configuration down, but bye-bye, it's going. And I just want to point out here that your pick is just based off of the elements group. It is not based off of the total number of electrons, where you're falling at the end of the day. It's all based off of the group number. So we have just O2 here. But we have to do a couple of things to this to make O2, make this configuration O2s. The first thing is we have to decide what S's and what P's are here. Are we talking about 2S, 2P, 3S, 3P? That comes from the period. And oxygen, group 16 or 6A, but in period 2. So we're going to be talking about the 2 S's and the 2 P's. All right. So 2's all around. Now just know that we're talking about sigma bonds and pi bonds, right? Those are your little notations here. And for every bond that you form, you will always form the antibonding equivalent. The antibonding is the star in the top. So here is a sigma bond, and I'm going to form the antibonding equivalent. And the same thing goes for these two, grouped together. Now, the thing here is that we have to put 12 valence electrons in this configuration. Just know that the way that I wrote it, you're starting with the lowest energy and working your way up. So you got to drop your electrons into your lower energy guys to get to, keep going on and on to get a total of 12 here. And just know that each molecular orbital, whether it's bonding or antibonding, they are only allowed 2 each, 2 max electrons each. So let's start from the beginning. I need to put 12 in total, so I'm definitely going to fill this one up, right? So there will be a 2 electrons being dropped in the sigma 2s. And now I keep going. I'm going to fill this one up, definitely, with 2 electrons in the antibonding one. I now have stated 4. I got to keep going. So I'm going to drop 2 more in here. So now I'm at a total of 6. And now just know that for this grouping, since you're saying that you have 2 molecular orbitals, you get double the allowed electrons. These are just in the same energy level. So I have 2 electrons here max, 2 electrons here. So this could technically be a 4. So let's see, if I do put a 4 up here, 2, 4, 6, and 6 plus 4 is 10, so I got to keep going. But I only have 2 left over because I want to get to 12, so I will put 2 in the last one. 2, 4, 6. 6 plus 4 is 10, plus 2 is 12, and we are done. So basically this last one, since there was no electrons in it, it could go bye-bye. And this is going to be the molecular configuration, the molecular orbital configuration for O2. And now, from here, we can find out the bond order. And maybe what I'll do is I'll post the bond order formula up top here. And I'll just make it a little small. So bond order is basically just the number of bonding electrons minus your antibonding. Now, the antibonding are easy to find because these are all the ones that have the star in them. So maybe what I'll do is I'll just put a line here because we're just going to do oxygen's bond order here. So I have my bond order, and maybe I will, I could do it over here, right? Bond order equals something minus something divided by 2. Well, let's see what they are. Go for those stars first. They're easier. Here's a star. I got 2 electrons here. That's antibonding. And here are also stars. 2 electrons here. So I got 2 total electrons plus another 2. So I have 4 total antibonding. All the other ones are bonding. So I have 2 more, so that's 4. And then these are bonding as well. So I have 8. So I have 8 bonding and 4 antibonding. Now we just got to do the math, right? 8 minus 4 is 4 divided by 2. 4 divided by 2 is 2. So I have a bond order of 2 for O2. Now what I'm going to do is I'm just going to work on the next ones. So what I'm going to do is, if I can, maybe, I guess I'll just take the molecular configuration. And now I'm just going to make this one O2 plus. Or actually, it's O2 2 plus. Now remember, a plus 2 means that you lost, right? Whereas a negative 2 means that you gained. So for my plus 2, I have to lose 2 electrons. And now you're losing them from the right to left. So here were my last electrons. I'm going to lose these. So in essence, this gets stripped away. That's 0. And if you don't have any electrons anymore in there, this whole thing goes bye-bye. So now it just makes it a little bit easier. So for this one, the bond order would be equal to something minus something divided by 2. Let's see, antibonding, check those stars. I got only 2 here now. So 2, and my bonding is 2, 4, 4 plus 4 is 8. So 8's still here. Let's figure out. 8 minus 2 is 6. 6 divided by 2 is 3. No units for bond order, by the way. And the last one is now going to be O2 2 minus. So always take it from the one that is the neutral one, where you did not lose or gain any electrons. So I'm going to put that one down here. This is now going to be the 2 minus. And remember, now I'm in a minus, so I'm going to gain 2 electrons. And you gain it from the last one. So instead of 2, 2 plus 2 is now going to be, the new number is 4. And now we can do the bond order. Bond order equals something minus something divided by 2. We have bonding 2, 4. 4 plus 4 is 8, so that didn't change. We still got the 8. But now, how many antibonding? 2, 4, so that's 6. Okay, so Let's do the math. 8 minus 6 is 2. 2 divided by 2 is 1. So there are your 3 bond orders. So the first part of the question is done. Determine the bond order for each member. There they are. So you got a bond order of 2 for O2, bond order of 3 for O2 2+, and a bond order of 1 for O2 2-. Now, which one is the strongest bond? Well, the strongest bond comes from the highest bond order. How simple is that, right? So now you're just ranking them. Since this one has the highest number, that means that the O2 2+ would be the strongest bond, because 3 means 3 lines. That would be a triple bond. This would be a double bond, and you got a single bond down here. So O2 2+ would be the strongest bond. And that's good for now. Let's color it in pretty. Oh boy. There you go. Okay, what'd you think? Hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. If you want to help us out, please hit that subscribe button if you haven't already. We're almost at 30,000 subscribers, and it just gets the word out there that this channel exists in the YouTube universe. Thank you. My brother thanks you. We're so grateful for you guys, and we're so glad that we're helping you out with your classes, not only in chem, but in physics and math as well. So if you're in those classes or you know anyone in those classes, tell your friends, tell your classmates. We might be able to help them out as well. I hope you're having a great day out there, and I'll talk to you soon. Okay, bye-bye.